Hey there, fellow science enthusiasts. It's your old pal Zakir Hussain here, ready to explore the electrifying world of static electricity. You know, that invisible force that makes your hair stand on end when you rub a balloon on it. Get ready to unleash your inner scientist as we delve into 5 amazing experiments that demonstrate the power of electrostatic force. So, put on your thinking caps, grab your safety goggles, and let's spark some curiosity. All right, science fans, let's kick things off with a classic, the balloon and hair experiment. This one's so simple, yet it perfectly illustrates how static electricity works. First, find yourself a nice inflated balloon. Now, find a volunteer with even nicer hair. The longer and straighter, the better. Got 'em? Great. Now just rub that balloon vigorously against your volunteer's hair. What happens? That's right. The hair starts to stand on end, reaching towards the balloon like it's trying to make a new friend. But why does this happen? Well, it's all thanks to those tiny little particles called electrons. You see, everything around us is made up of atoms, and atoms have these even tinier particles called protons, neutrons, and electrons. Protons are positively charged, electrons are negatively charged, and neutrons, well, they're neutral, no charge at all. Now, when you rub the balloon on your hair, you're transferring electrons from your hair to the balloon. The balloon becomes negatively charged, while your hair, having lost some of its electrons, becomes positively charged. And remember what we learned about charges? Opposites attract. So, the positively charged strands of hair are attracted to the negatively charged balloon, causing them to stand on end. This experiment shows us that static electricity is all about the movement of charges. When objects with different charges come close to each other, they create an electric field, and that field is what causes the attraction or repulsion between them. Pretty cool, right? Now you can try this experiment with other materials too. Try rubbing a wool sweater on a plastic comb or a PVC pipe on a piece of fur. See what happens. You're creating static electricity. Ready for another electrifying experiment? This time we're going to bend water with the power of static electricity. It sounds like magic, but it's just science, and it's super easy to do. For this experiment, you'll need a plastic comb or a balloon, a water faucet, and dry hair or a wool cloth. First, turn on the water faucet so that a thin, steady stream of water is flowing. Now, take your plastic comb or balloon and rub it vigorously on your dry hair or a wool cloth. This will charge up the comb or balloon with static electricity, just like we saw in the previous experiment. Now slowly bring the charged comb or balloon close to the stream of water without letting it touch the water. Watch what happens. The water stream bends towards the comb or balloon, as if it's being pulled by an invisible force. Amazing, right? So, what's going on here? It's all about those charges again. The charged comb or balloon creates an electric field around itself. When we bring it close to the water stream, the water molecules, which are polar, meaning they have a slightly positive and slightly negative end, are attracted to the charged object. The positive ends of the water molecules are attracted to the negatively charged comb or balloon, and vice versa, causing the water stream to bend towards it. This experiment demonstrates how static electricity can influence the behavior of other objects, even something as seemingly simple as water. It's a great reminder that invisible forces are at work all around us, shaping the world we live in. Have you ever tried to separate salt and pepper after they've been mixed together? It can be a real pain, right? Well, not anymore. With a little help from static electricity, we can separate these two seasonings with ease. For this experiment, all you need is some salt, some pepper, a plate, and a plastic spoon or balloon. First, sprinkle some salt and pepper onto your plate, making sure they're well mixed. Now take your plastic spoon or balloon and rub it vigorously on your hair or a piece of wool cloth to charge it up with static electricity. Now hold the charged spoon or balloon just above the salt and pepper mixture without touching it. Observe closely. You'll see the pepper particles magically leaping up towards the spoon or balloon, while the salt particles are left behind. It's like the pepper is suddenly developing a taste for plastic. But why does this happen? You guessed it. It's those charges again. Pepper is lighter than salt, and it also has a weaker hold on its electrons. So when you bring the charged spoon or balloon near the mixture, the pepper particles are more easily attracted to the electric field and jump up to meet it. Salt, being heavier and holding onto its electrons more tightly, is less affected by the static charge. This experiment is a fun and visual way to show how static electricity can be used to separate different materials based on their properties. It's also a good reminder to always check your salt shaker before you use it. You never know when static electricity might have been playing tricks on you. Time for another classic experiment that demonstrates the power of static electricity, making a balloon stick to a wall. This one's so simple, you've probably done it before without even realizing you were conducting a science experiment. All you need for this one is a balloon and a wall. That's it. First, inflate your balloon to a nice round shape. Now, rub the balloon vigorously on your hair or a piece of wool cloth for about 30 seconds. Make sure you rub it all over to create a good static charge. Now hold the balloon up to the wall and let go. What happens? The balloon magically sticks to the wall, defying gravity. But how is this possible? It all comes down to those amazing little particles we talked about earlier. Electrons. When you rub the balloon on your hair or the wool cloth, you're transferring electrons from your hair or the cloth to the balloon, giving it a negative charge. Now, when you bring the negatively charged balloon near the wall, something interesting happens. The wall, being an insulator, doesn't allow electrons to flow freely. However, the electrons in the wall's atoms are repelled by the negative charge on the balloon. This causes the positive charges in the wall's atoms to become slightly closer to the balloon, creating an attractive force. This attractive force between the negatively charged balloon and the positively charged surface of the wall is strong enough to overcome the force of gravity, causing the balloon to stick. For our final experiment, we're going to build a simple electroscope using aluminum foil. An electroscope is a device that detects static electricity, and it's surprisingly easy to make with everyday materials. For this experiment, you'll need a glass jar, a cardboard lid, a piece of wire, aluminum foil, and a balloon. First, carefully poke a hole in the center of the cardboard lid. Cut a piece of wire about 6 inches longer than the height of the jar. Strip about an inch of insulation off both ends of the wire. Push one end of the wire through the hole in the lid and bend the wire at a 90-degree angle on the underside of the lid. Next, cut 2 small pieces of aluminum foil, about 1 inch by 2 inches each. Fold the pieces of foil in half lengthwise to create 2 thin strips of foil. Hang the foil strips onto the bent end of the wire inside the jar, making sure they're hanging freely and not touching each other or the sides of the jar. Screw the lid onto the jar, making sure the wire is secure and the foil strips are hanging straight down. Now it's time to test our electroscope. Inflate your balloon and rub it vigorously on your hair or a piece of wool cloth to charge it up with static electricity. Slowly, bring the charged balloon near the top of the wire, but don't touch it. What happens to the aluminum foil strips? They magically move apart from each other, as if they're being repelled by an invisible force. That invisible force is, of course, static electricity. When you bring the charged balloon near the wire, the electrons in the wire are repelled and flow down to the aluminum foil strips. Since both strips now have the same charge, negative, they repel each other, causing them to move apart. The electroscope is a simple yet powerful tool for detecting static electricity. You can use it to test different materials and see how much static charge they generate. It's a great way to explore the world of electrostatics and learn about the fundamental forces that govern our universe. Well, that's a wrap on our electrifying journey into the world of static electricity. I hope you had as much fun exploring these 5 amazing experiments as I did. Remember, science is all around us, waiting to be discovered. So keep your curiosity alive, keep asking questions, and keep experimenting. Try these experiments at home and impress your friends and family with your newfound knowledge of electrostatic force. Who knows what other amazing discoveries you might make? Thanks for watching. Don't forget to like, share, and subscribe for more science fun.